Hello, everyone. I am Nicolas Saint-Lay. I'm developer at Odoo. I've been a technical consultant for 5 years at Odoo, and then I'm now part of the internal team in Odoo. The internal team is in charge of maintaining and deploying the SaaS, Odoo.com, and all the databases you can create on Odoo.com. Today I will talk about the Python performance. My colleague Victor will talk about the SQL performance after this talk. It's a bit complicated to split between the Python and the SQL part when we deal with performance because they are all linked together. It's writing bad Python code will lead to bad SQL queries. So it's not that easy to split between the two, so I'll do my best. There is a pad, a collaborative pad, with the address here. You can write down your questions if you have any, and I will answer to all the questions after the talk. And I will try to stick to 40 minutes talks and 10 or 15 minutes answering the questions. When you deal with Python code, that's the recipe to make an efficient algorithm. You have to make it work, then make it right, and then make it fast. And you don't have to mix this order. Make it work is quite easy. Making it working means having your continuous integration server acting and saying that your code is working and not failing. Then you will make it right, and you will ensure that all your code is doing what you expect it to do. So you will write some unit tests to ensure that your code is really doing what you want it to do. And then you will finally make it fast. Generally speaking, making things fast means writing less clean code, making algorithm a bit more complex to have them act more faster. So doing it fast prior making it right means you will have a complex algorithm which is not doing the right thing. So it's better to have it right and then make it fast. What does fast means? It's a matter of subjective for everyone, so it's not the same for everybody. To achieve the performance, the first rule is modeling is key. You can't achieve a correct performance with bad design. If your system is badly designed, with bad models, with wrong models, you can't achieve an efficient algorithm. You should also be aware of the algorithmic complexity. If you write all algorithm O(n) squared, everything will be slow when going to production. Reducing the number of SQL queries is not always the best case, but at least at the beginning, it's a good measure to ensure your process is faster. Of course, you will always find use cases where running two small SQL queries is faster than running a bigger one, of course. But generally speaking, it's better to reduce the number of SQL queries. Reducing the number of SQL queries will makes you follow some common sense rules like not searching in a loop. You are not executing the same thing multiple times. And the ORM of Odoo will help you by reducing the number of SQL queries. We'll see later why you have a lower number of SQL queries when running the ORM of Odoo. And of course, you have to measure. You have to profile what you are doing. If you don't measure, you can't improve. You cannot improve what you are not measuring. If you don't measure the time taken to execute an algorithm, it's not possible to say that you have improved it. I will show you some tools today, but the best analysis tools you have is your common sense. Okay? I will not give you any tools better than this one. Someone said that common sense is not common, but this is your best tool. If you see that you have slow SQL queries, you should probably have to look at your database. If you see that your Odoo server is burning CPU, probably you have to look at your Python code. If you already mastering any Python profiler, just keep it. I will show you some profiling method today, but if you are mastering one, keep it and continue to use it. It's probably better than any tool I will show you today. I will show you mainly 3 methods of profiling. But if you have a different one, this one is probably better than anyone I can show you today. This is the first profiling tools, and it's available for everyone. If you had ever looked at what the Odoo logs are, here is a common log line for an Odoo call, whichever the call. You have 3 figures at the end of the log line. The first figure is the number of executed SQL queries. If your call is searching for a product, and you see here 1,000 queries, probably there is something wrong. The second figure is the time taken to execute the queries. No matter the number of SQL queries, this will give you the time spent by the database to execute all the SQL code you sent to this database. And finally, the third figure means the time spent answering the query except the SQL execution time. So the total execution time for answering this call to Odoo have been the time in SQL plus the time except SQL. So in this particular use case, the system spent more time in SQL rather than in Python. This is where you should use your common sense at the first sight. Just read the logs. Just have a look here. And then you will decide, should I have a look at the Python code or should I have a look at my database? If I see here one query which takes multiple seconds, multiple minutes, probably I have an issue over there. The time except SQL also means the time spent calling external APIs. If your call to the Odoo means calling an external API and you have higher latency, network latency, whatever, the time will be reported in the time except SQL. So sometimes the third figure doesn't mean only Python code. It can also include time spent waiting and other stuff. No, this is the second method of profiling. This is the hardcore one. The main advantage of this method is it's the simplest you can find, ever. Sadly, the command is not really meaningful, I think. It's the simplest to do. So if you launch Odoo on any POSIX machine, you can send a signal to the process with the kill command. Kill doesn't mean killing the process and having it broken. The kill -3 is a signal you send to a process. And Odoo is able to handle the kill -3, which is SIGUP signal. It can handle the SIGUP signal, and he interpret this as output the stack trace. If you send kill -3 to an Odoo process, you will get in the logs the stack trace. The stack trace is the list, the pile of called method at the time you send the signal. When you start an Odoo server, in the Odoo logs, Odoo output the process IDs. If I have a look at the previous logs, here in the logs you also have the PID. The PID here is 1, 2, 3, 4, 5, 6. If I send a kill -3, 1, 2, 3, 4, 5, 6, I will get the stack trace of this given process. It works in production. It doesn't kill the process, so the process will continue to work. It just output the stack trace and continue his work. You'll get the result in the logs. Then you are able to send the signal once, you'll get the stack trace. You can continue to send the signal multiple times. If you send this signal multiple times, you will get the stack trace at each time you send the signal. That means you can roughly follow what Odoo is doing and which method are called. If you see that each time you send this signal, Odoo always output the same method, you have found the method in Odoo where Odoo is executing codes. Maybe he is outputting a stack trace because he is waiting something else than just executing code. It depends on your code, but you have an idea where to look at, and you have a rough idea on what you have to improve. So you need a console access to the machine, but this method is completely safe to use. Okay? This is the second profiling method. It's not the nicest one. So there's probably better profiling method than this one. And Odoo is embedding his own profiling system. The advantage of this embedded profiling system is that it's embedded in the UI and it's available in the community version, so you don't need the enterprise version to use it. An admin of Odoo should enable it. That means an end user cannot use the profiling without the right to do it. So an admin should enable the profiling. He will enable the profiling for a given amount of time. Once done, you are able to profile what's executed in Odoo. You can profile the SQL queries, you can record the stack trace, you can also debug QWeb. Here we are talking about Python, so I will just stack with the Python method. I will not go deeper in the QWeb profiling. That means if an end user have an issue, you can enable profiling and ask the end user to record what he is doing and feels the stuff slow. To go there, you have to be in debug mode, so probably if you need an end user to do it, you probably have to show him how to go in debug mode. It's not obvious for everyone how to go in debug mode. Each time a user will use the interface, the system will record what's going on. He will give you all the calls done by the user, and you can, as an admin, you can go here, choose any of the trace you have here, and with those traces, you'll have the evolution of the stack trace during time. That's the exact same result as the one you have with skill -3, except this one is done every 0.1 second or stuff like that. Maybe more, maybe less. I'm not sure about the granularity of the result. So those are the three methodologies to profile the code and check if something is slow, and if something is slow, check where is the stuff which is slow. Okay, now we have located the place where the code is slow. To improve something, you have to reproduce the issue, and you have to reproduce it in a manner you can reproduce it as many times as you need, and in a way it's always the same thing. You can achieve it with any method you want. I'm just suggesting one, but if you want to use another one, it's good for me. So I will use a script to reproduce the issue. An issue is just a call to Odoo, so I have to just reproduce the call, which is slow. How do I do it? I will use it XML RPC, and I will use a library to reproduce the issue. And the code I will write using the library of Odoo using XML RPC or JSON RPC is quite like the one you will find in Odoo. The main difference is here, each line is a call to the server. As each call to the server is within a transaction in SQL, here we have multiple transactions in SQL. If you write this code in a method in Odoo, you will have only one transaction embedding all the code. So that's the main difference. So you have a different transaction between the search and the read in this case. There is other methods to reproduce. You can use bare XML RPC libraries in any languages. Here, I'm showing it in Python because I'm more comfortable with Python, but every language mainly have an XML RPC library. And if you go to odoo.com/documentation, you will find many samples of multiple languages using the XML RPC language. Or you can use a higher level library like Odoo Client Lib, or you can even use more advanced method like Odoo Locust. We already have shown how to use the Odoo Locust in different talks. The main difference between Odoo Client Lib and Odoo Locust is when you use just XML RPC, you are reproducing an issue that happens when you are alone on a machine, and the Odoo Locust will allow you to reproduce an issue when the system is under load. The Odoo Locust tool is a tool to load test the machine. So you will create a big amount of load on the machine and check what happens when the machine is under load. From the database point of view, if you search for something in the database, the system will put the operating system will put the data from the disk in the cache of the operating system, I mean. If you have a system under load and you request plenty of data, there is a chance that when you request the same data the second time, the operating system have discarded the cache. So putting a system under load can show different issues than the one you are when you work alone. The second advice is test with enough data. Avoid testing with the customer database. Okay? And even worse, do not test on production database. Okay? We don't test on production database. We don't test on the customer data. If we don't test on customer data, how can we reproduce the issue which comes when you have multiple data in your database? Either you can use the demo data, but the demo data are really small data set, so it's not enough. As it's not enough, there is a tool in Odoo which is called Populate, which will makes you able to create data within your database. The Populate method makes you able to create different data sets from 3 different sizes, from medium to large. When you populate a data, a class, you probably need data from other classes. So you have the populate dependencies to wait for another model to populate before populating yours. Let's say you want to create a company with invoices. To create invoices in a company, you need to wait for the companies to be created prior creating the invoices. You know your models. You know your business. You know what you are talking about. You have to create realistic size data sets. It's not necessary to create 10,000 companies because nobody has databases with 10,000 companies. But if you create 5 customers, you are also probably wrong. So choose the right size for your data sets. And to populate a database, you just have to launch the Odoo in command line stating populate. You can choose which size of population you want to provide to your database and on which database. You can populate a database only once. If you try to populate twice a database, you will get issues. You will get unique keys, constraint issues, and so on. So it's not possible to populate a database twice. I stated prior that it's complicated to split between Python and SQL code because when you write business code, you will use the ORM. The ORM will deal with its own cache and will deal with the database through the PsychoPG tool. The point of improvement is the way you will be able to play with this cache. The better you are able to play with the cache using the ORM, the better. The more cache, the faster. Here are the basics of the way the ORM cache is working. As an example, we have a model, we have a record set, and we will access one field of this record set. What will happen when in my code I wrote my model.myField? What is triggered? The ORM will check, is my field in memory for the record, my model? If it's in memory, no problem, return it, it's in memory, that's it. Other case, it's not in memory. If it's not in memory, then there is a mechanism called prefetching. The prefetching means read from the database and put in memory. Once it's in memory, we will fall back to the first use case. But what will Odoo prefetch? It will not prefetch all the database. You don't have enough memory to prefetch all database. So the ORM needs to know what to prefetch. The ORM is not a compiler. So as it's not a compiler, it doesn't know what will be your next line of code. It's not possible. It can only guess what will happen. Which are the guesses will he do? Probably, if you are reading a field from a record in a record set, you will probably read this field for all the record in the record set. That's the first guess. Second guess. You don't have enough memory to read all the data from the database, so we will limit to 2,000 records at a time. We will put from database to memory 2,000 records at a time. Which fields will you store, will you put in memory. It's faster to take all fields from database and put them in memory rather than pulling one field from the database to the memory each time you access another column. So this the second guess is we will put all the stored field from the database to the memory. All the stored field except the binary fields, the properties, and the ID fields. It's also possible in your code to change this behavior by setting the prefetching false in the property of your fields. If on one of your field you set prefetching equals false, this prefetching mechanism will not take your field into account. There is two hard problems in programming. The two hard problems in programming are invalidating the cache, naming the variables, and the off-by-one errors. We have a cache, we should invalidate them. Let's deal with the cache. Play a bit with the cache. Here we will deal with a computed field which is not stored. Reading a non-stored field means you cannot retrieve the value from the database. As you can't retrieve it from the database, you have to compute it. Because you have to compute it, you will compute it with its dependencies. So here we have a simple compute method which depends on two fields. When you will read full name, the system will go in the compute method. For all your partners in your record set, it will compute the full name as the concatenation of the name and the name too. So when you will access to name, prefetching will occur. It will store all the stored fields in memory. Probably it's not necessary in your use case. So we will store plenty of information in memory, and maybe we don't want to store this. I will tell the ORM what to do. I will give an insight to the ORM. If I call self.fetch name2, it will only prefetch two fields. And then the compute method will not trigger the prefetching because we are in the first use case. I access a data, it's in memory, I return it, and so on. This is a way to give hints to the ORM to faster your code. The problem is you override the compute method and it needs a third field. So in your override, you also need to give hints, or he has prefetched two fields and then he needs to fetch all of the fields. You lose everything. There is bad ways to use record set. When prefetching, I said that when you access a field, the ORM prefetch the fields from the record set. Here, instead of looping on self, I'm looping on the length on self, and I'm use self square I. I'm cutting the record set. The prefetching occur on one record per record. We are losing everything. It's the worst you can word. It's not possible to write a worse method than this one. The ORM is very cool. If you ask a database consultant what to do, the first advice he will give you is do not use an ORM. That's the first you will receive. I will show you the exact opposite. The ORM will cache everything. That means when you write something, it doesn't really write it to the memory until it's necessary. It will keep the values as much as it can. Here is an example of in SQL. It's pure SQL. I know I should talk about Python, but this is pure SQL. Here, I'm updating the same partner multiple times. It takes less than a millisecond to update the partner. After 3 times, I decide to start a transaction. I update it again. You know that I'm still setting the same value, so I'm not writing anything. If I'm within a transaction, the first time it takes exactly the same amount of time as usual, but the second time it's 10 times slower. And this is because when you update a record multiple times within a transaction, from the second time, PostgreSQL will check the constraints of the record. So having the ORM keeping in cache and only writing when necessary will discard this crappy use case. So the ORM delay the update, and setting a value to a field will not trigger any query. The update will be grouped together at the end of the transaction. Of course, there is a trade-off. Because everything is in memory, if you need to execute queries, the stuff is in memory in Python, and the database is not aware of it. So if you want to really execute a query, you'll have to tell the ORM to push what he has in memory to the database. And if you modify stuff in SQL in your database, you have to tell the ORM that what is in memory is not valid anymore. I remind you that the cache is one of the more complex problems. The cache invalidation is one of the most complex problems. The other problem when dealing with SQL is the security. You don't see them when you write code, but when you write code, the ORM automatically adds the record rules to all the queries you are issuing. If you issue queries on your own, you will bypass the model access and the record rules. You will also bypass all the Python constraints. My advice is don't use SQL directly, except when necessary. And the worst here is using SQL triggers. SQL triggers is the worst you can do. If you use SQL triggers, you will trigger stuff in the database the ORM is not aware of. Should you use SQL or Python constraints? The SQL ones are the fastest ones, while the Python ones are the slowest ones. But the SQL ones are the safer. The Python ones can be bypassed when under load. But the Python ones are way more easy to update, way more easy to maintain. And normally, as an Odoo developer, you are used to write Python code and not SQL code. So it's quite more easy to maintain the Python constraints, even if the fastest ones are the SQL ones. I will show you a nice example of bad code. Here, I have a model with 2 compute methods. The one is just compute, and the other one is compute store false. That's what I have in my model. And I will just read the full name in file. This will trigger the reading of a non-stored field. Because it's a non-stored field, we compute it. That's what the ORM will do. But the compute method is the same for the both fields. What happened with the other field? It's computed. The compute fields are non-stored by default. So here, it will compute and set in memory the full name, even if we don't read it. Here is quite the same model. The main difference is The first is store true, and the second one is not set. That in this method, I will continue to read the second field. What will happen? You read a non-stored field. It's a non-stored field, you compute it. You compute it, the compute both values. The other value should be stored in a database. The system will write. In the second use case, it looks like the first one, but here you are creating an issue because when you will read the full name in the file, you will write in the database and you will lock records. Because of the compute store true, you should not mix compute store and compute non-stored. It's a very bad practice. It's also even bad practice that it can lead to put your production down. That's what we are talking about. In the new version 17, there is a warning. If you do so, the ORM output a warning. You can have exactly the same with the compute pseudo. You have a field which is computed in pseudo, and the other one is computed without pseudo. What will happen? Whichever the user who triggered the compute, the value should be the same. You cannot have a computed field which will rely on a given user, on a given environment, on a given currency in the context, on a given language in the context. You cannot rely on the context. I know I should talk about Python, but I will introduce something in SQL. I will debunk some urban legend. And this is the urban legend. So when a field is indexed, Postgres will automatically use it. As it's a urban legend, of course it's false. The usage of an index is based on statistics. The way statistics are computed are in PostgreSQL is quite simple, but mainly it's just an histogram of the values, and given a value, PostgreSQL can estimate how many records corresponds to this value. That's roughly how it's working. He also have the 20 most frequent values, and he have the null proportion in the table. So if you give him null, he can say how many % of the records he will retrieve. That means when you will search for some stuff in the database, PostgreSQL is able to compute the time it will take to scan the index and go to the table after, or just scan the table. If you have a business with multiple companies, you have one big company and small companies, and you say, I will index the company ID, the index on the company ID will sadly be used only for small companies and not for the biggest one. It's a bit frustrating, but it's the way it's working. If you index the active field on a model, it will only be used for active false. Again, it's frustrating, but it's mathematical. Another important stuff is field value are not correlated in PostgreSQL. If you have, again, or databases with 10 companies, each company is roughly doing 10% of the business. So each company have one accounting journal. You give PostgreSQL one accounting journal, he know that an accounting journal will return 10% of the move. You give him one company, he know that this will return 10% of the records. If you give him one accounting journal and one company, you know that they are linked together. PostgreSQL doesn't know that. So 10% of 10% is 1% of the records. As the fields are not correlated in PostgreSQL, if you give a where clause with two fields which are linked together and don't tell PostgreSQL they are linked together, he will consider that it's not correlated, and it will make wrong assumptions on the data size. The way PostgreSQL execute a query is called an execution plan, and he try multiple execution plans, and he choose the one with the lowest cost. Each operation, a sequential disk, random disk access, CPU, etc., have cost. He makes the sum of the cost for each plan, compute the total cost, and choose the one with the lowest cost. When times comes to search in your database, it's generally when the things comes to be slow. A way of doing it is using this method. I will search for whichever product and from whichever table. This will give you a list of IDs, and you give that in as an input to the next domain. Yeah, but will this return 10 records or 10,000 records? Because putting a list of 10 IDs is quite good. 10,000 IDs it's not that easy. Here, you have a method in code. Instead of putting the IDs to the domain, is using an operator called inSelect, and you can return a query. You can give a query to the inSelect in the domain. This will trigger a subselect when you will search in the database. It's faster when you have plenty of IDs. But there's no silver bullet. It's not all. There is not one of the both cases which is faster every time. It depends on your model. The other point was here is also I'm using direct SQL. What about the record rules? Since version 16, I think, there is an operator called _search. So here is the casual way of doing subsequent searches. I will search for lines, and then, given the lines, searching the orders linked to those lines. This will perform two select queries. The first one will return a list of IDs, and the list of IDs will be put in parameter of the second search. This will inject IDs, just as the previous example, but this is record rules friendly. There is another way of doing it. You will use _search. _search, despite search, will not return the list of IDs. This will return an object which will trigger a subselect. And this object can be put in parameter in a domain. The second way of doing the stuff here, trigger only one query. Instead of two queries, you have only one. This is still user-friendly. It doesn't inject IDs anymore. You achieve exactly the same result. The subquery is efficient. It's not ordered. The first example executes two queries, but the line search will order the result. Despite the fact you don't care about the order, here it's ordered because search by default is ordering stuff. And ordering is PostgreSQL is taking time. The second version doesn't use the order. But you have two lines. You have to write line queries and then the search based on the line query result. There is a new operator, any. So any will produce exactly the same as the second example of the previous slide, but in just one line. And the subdomain in any will be handled by the _search. So it's the exact same result at the end. The other advice is a hidden culprit of the performance is the _order clause. The _order clause is not doing what you think it's doing. Here we have courses and sessions, and the sessions are sorted by course and instructor and ID. Sorting a session by course doesn't mean sorting by the ID of the course. It means sorting by the order clause of the course. Searching on a name of the session, searching sessions based on their name will trigger a join between the session and the course just for the sorting. If you don't care about the sorting, put an order clause in your search. At least order equals ID. If you said order equals false, the system will fall back to the default ordering. So the ordering with many-to-one means ordering by the order clause of the many-to-one. It's hidden. You don't see this in the code. I'm sure when you read a class and method, you don't even look at the order clause. And finally, you have done all your job. You have monitored. You have load tested. You have improved everything. Everything is running fine. And then an end user came and kills your performance. How does an end user kills performance? They use filters in list views. In list views, they use filter with crappy searches. What will they use? The most obvious one is searching on a name of a many-to-one instead of the ID of those many-to-ones. If you search for orders linked to the country Belgium, don't start by searching country I like Belgium. Say country equals the Belgium country. It's way more faster. The way PostgreSQL doesn't like to search is excluding stuff. It's faster to include rather than excluding. Instead of excluding leads from EU countries, it's better to include the one from non-EU countries. It's way more faster. Thank you. I have some questions here. So, do we have time? If I don't have time to answer your queries, feel free to ask me after the talk. It's not an issue. Does the Odoo Profiler tool works for cron calls? No. Because it's in the UI, so it's not working for the cron calls. Is there a way to connect, export the three measures to a monitoring tool? Yeah. The logs are text files, so I'm sure you can parse a text file and monitor whatever you want. When did the Odoo embedded profiler was introduced? I think it's 16, maybe 15. Prior to that, there were a method decorator to profile some methods. But if I remember correctly, this profiler was more costly than any Python code, and he was hiding everything because of the way it was measuring stuff. So I would say 15, but I should have a look. So the embedded profiler is just the stack trace and the time spent on it. Yeah, it's just the stack trace over time, but it's what you are looking for, because if you see a long bar, that's the method who takes time. It's a flame graph. Is Odoo considering implemented REST API alongside XMRPC? No. It's not performance related, but no. Is there a way to populate specific table rather than the whole database? No. It's not okay to test on a neutralized copy of production data? Yeah, you can test on neutralized copy, but once you will forget to neutralize and you will send production emails from the customer database or so on. So no, it's not okay to work on a neutralized database. And by the way, even a neutralized database, you have a copy of the customer database on your laptop. Someone stole your laptop. What will you do with those data on your laptop? ORM cache, does it mean it's recommended to have one big server rather than a cluster of 5 small servers to handle load? No. The cache is a per worker cache. And each time a request comes to the Odoo server, it starts with an empty cache. So you can have as many workers, as many servers, it doesn't matter for the ORM cache. ORM read all feeds at once. Does it mean that using search is better than search read? No. Search is just searching and retrieving IDs. So it doesn't imply reading fields from the models. As it doesn't imply reading fields from the model, it's not using the cache in any way. So search read will search and then read and put stuff in cache. Search will not search for anything. Search read is sometimes a convenient way to improve a compute method, because in search read you will give hints to the ORM what you want to read, and then what you want to prefetch, then what you want to put in memory for your compute method or your algorithm. Why do I have a purple SAP sticker on your laptop? Because it's funny. New domain, new underscore domain is also available for V16. You should ask Raphael. Raphael Collet is the one who wrote the ORM, by the way. All developers are available there in the developer zone. If you have questions, feel free to come in the developer zone. I'm mainly there. Raphael is over there. The JavaScript, Python, and all applications developer are over there. Feel free to ask questions. It's the time to ask questions, by the way. Underscore search is already available from version 13. Should check, but if it's available, it's returning a list of IDs. So it's not improved the way it's improved here. So if you have such kind of code, just upgrading Odoo you will benefit from the new way it's working. Does the order logic problem with many-to-one only happen with ORM search method, or also when record set are fetched? No. It's only a problem when you search for some stuff. When you read stuff in the order you ask him to read them. But when you search, it's business-wide that the underscore order clause is important for showing data to the end user, whichever the location you show them. You will show data in list view, in one-to-many tree views, in Kanban views, and so on. So it's important to have them sorted always the same way. If you don't order items always the same way, you don't have reproducible ways of doing stuff. Maybe you will search in one order and then another order, and something will trigger differently because of the order. So it's important to have them ordered always the same way. But in your algorithm, when you are performing search and you know that the order is not important, you can specify the order clause to avoid sorting stuff. Are there many differences in older version of Odoo? Yes, obviously. I think the ORM team is a bunch of 4 people working full-time, so they do stuff, they improve stuff. Yeah. If you want a deeper insight of what has changed from one version to another, came with questions and we'll try to answer it. Can I prevent end-user search with I like in filters? In the search view, you can specify the domain. So you specify the field and you can specify the domain. So you can override the I like search by setting something else, but the end user always have the advanced search where he can set everything he wants. So if he really wants, he can search for I like. And by the way, searching for I like is very important. My colleague Victor will explain you how to improve that in 10 minutes, 5 minutes. In 5 minutes, you will be learn how to improve an I like search, so it's not an issue. Cannot serialize access on the database. Is there a strategy to avoid concurrency DB issues? Okay, so serialization failure is the way of Odoo to prevent crappy stuff to happen. It's safer to see them in the code rather than not seeing them at all. Each call in the ORM is done within a transaction. This transaction has an isolation level. Of course, you can see records people are currently creating because maybe they will roll back their transaction, so the record will be not really available. So you don't see, you only see what is already committed in the database. And we are in isolation level, which is called repeatable read. This repeatable read means each time you read a record, you always get the same result, no matter what others are doing. So the serialization failure means someone else modify something in the database that makes your algorithm not acting like he wants. You read data from the database and you take in your code business decisions on what you are reading. If someone changed what you have read, you should change your business decision. This serialization failure makes Odoo roll back the transaction. Each call to Odoo is in a retry clause. It retry 5 times the same call. So when you have a serialization failure, there is a 1/5, 2/5, and so on behind. That's because Odoo will retry to do it. It will start again a new transaction and restart your code. So prior having an end user seeing a failure, Odoo already tries 5 times the call. Can you force prefetch binary fields? If you read, probably if you read them, but I'm not sure. I should test. Can you explain again the 2 fields with the same compute method? Come to see me, I will show you in details. It's better than telling everyone the same stuff again. If PostgreSQL does not use index, how do I know it? How to force it? Stay tuned. My colleague will explain. Difference between write and record fields equals on computed method. There are subtle differences, some which are historical, but we can show the difference between the two. Feel free. Time's over. I should leave. So I'm available here. Feel free to come. See you next time.